All right, welcome to The Explainer. Today we're going to dive deep into the fundamental logic of large language models. We're going to uncover the two distinct souls that really drive how they think, learn, and even speak. And believe it or not, it all comes down to this single sentence. It might sound a little poetic, sure, but this isn't just some clever analogy. It's actually a shockingly accurate blueprint for how these massive AI systems work. This is our key to the whole kingdom. So the big question is this just a nice turn of phrase, or does it manage to snap the entire complex architecture of artificial intelligence into perfect focus? Well, let's find out. Okay, so to really get this, you have to know that every large language model has two totally separate phases in its life. And these aren't just steps in a workflow, they are fundamentally different ways of being, two different moments that define everything the model does.
First up, there's training. You can think of this as the LLM's childhood. It's school years. It's the student, just soaking up massive amounts of text, making a ton of mistakes, and constantly tweaking its internal brain connections, its weights, to get smarter. And then you have inference. This is the LLM as the adult, the oracle. The learning is over. Its weights are frozen in place. Now its job is to act. It takes your prompt and generates a response, one single word at a time.
And here's the kicker. These two modes are driven by completely different questions. Training is all about reducing its own confusion. It's constantly asking, how can I change myself, my internal wiring, so that the world makes more sense, so I'm not so surprised by the next word I see. But inference, it's asking something else entirely. It asks, okay, based on who I am now, based on everything I know, what's the most likely thing to say next? Okay, so let's dig into that first soul, training. This is where Claude Shannon, the absolute father of information theory, comes into the picture. Because at its heart, training is all about information, uncertainty, and maybe most importantly, surprise. This, right here, is the core idea of how an AI learns. The whole point of training is to become less and less surprised by the information it sees. Every single time it guesses the next word wrong, that feeling of surprise is a powerful signal for learning. It forces the model to take that shock and use it to build a better, more accurate internal map of how the world works. So how does it feel, that surprise? Well, it's driven by a mathematical idea called cross-entropy. But honestly, a much better way to think about it is as artificial pain. It's basically a penalty score. When the model makes a bad guess, when reality surprises it, that cross-entropy score shoots up. That pain is the signal that screams, you were wrong, change something. So this absolutely massive, mind-bogglingly huge process, it really just boils down to a simple, relentless loop that happens over and over. First, the model predicts. Then, it measures its surprise, that artificial pain. After that, it corrects its own internal wiring to try and avoid that same pain next time. And then, it repeats. It does this billions and billions of times, until the world just isn't that surprising anymore. Okay, so that was the student. Now for the second soul, inference. This is where the fully trained model, the oracle, actually gets to work. Its personality is all set, and now it has to talk. And to understand this, we need to bring in the physicist Ludwig Boltzmann and, believe it or not, the laws of thermodynamics. Right at the center of inference is this function called softmax. So the model has all these raw hunches about what the next word could be. You can call it semantic pressure. Softmax is like the mathematical gatekeeper that takes all that messy pressure and turns it into a clean, neat probability for every single possible word. It turns a chaotic competition of ideas into a final, concrete choice. And the coolest part is, we can actually control this process with a setting called temperature. It works just like you think. A low temperature makes the model really rigid and predictable. It'll almost always just pick the most obvious, highest probability word. But if you crank that temperature up, it starts to get more creative, a little more random, and it's willing to explore some of the less likely, but maybe more interesting options. So here's the really crucial thing to get. An LLM is not just looking up an answer in a database. It is building it word by word through this exact process. Your prompt creates a specific shape in its huge map of meaning. That shape creates these raw preference scores for what words might fit. Softmax turns those scores into probabilities. And finally, one single word is picked. Then the whole thing starts over for the very next word. So we've got these two very different processes, right? We have Shannon's training, which is all about learning from surprise, and we have Boltzmann's inference, which is about choosing the next step. The question is, how do these two souls actually connect and work together? And this, right here, is the central idea of the whole thing. It's actually kind of beautiful. The Shannon process, the training, is the mapmaker. It spends an incredible amount of energy compressing the entire world of language into a huge, complex map of meaning. Then, the Boltzmann process, inference, is the explorer. It's the one that actually walks a path across that map, one step at a time, to give you an answer. This gets to the very heart of how an AI thinks. Inside that map, the word king isn't a dictionary definition, nope. It's a specific location, a point in a massive web of ideas. Its meaning comes from its position relative to queen and royalty and power. So before an LLM even says one word, your prompt creates a shape inside this giant conceptual space. Okay, so let's zoom out from all the technical stuff for a second. When you look at this whole architecture, this two-part system of building a map and then walking across it, it starts to look, well, surprisingly familiar. Actually, it looks a lot like processes that we see everywhere in the natural world. I mean, think about it for a second. The long, slow, incredibly energy-intensive process of training, where the model builds its brain by adapting to its environment, doesn't that sound a lot like evolution or like an animal developing its nervous system? And then the fast, real-time act of inference, using that structure to act right now, is an amazing parallel for cognition itself. And that means we can bring it all home and state the entire unified theory in just one sentence. One process, training, builds an internal map of the world by trying to get less and less surprised by it. And the other process, inference, uses that map to act by carefully choosing what to do next from a field of possibilities. One builds the structure, the other navigates it. You know, what this suggests is that the LLM isn't some strange alien technology that just popped out of nowhere. Instead, it looks like it's another kind of engine, built on one of the deepest bargains life ever made, that constant struggle to turn uncertainty and energy into ordered, meaningful action. It seems to share a blueprint with biology itself. And that just leaves us with a really profound question, doesn't it? If that's true, what comes next?